Hi, Lawrence Harris here from WRS International. We're here at our head office in Menin, Belgium, and we're undergoing the pull test of a PVC D-Ring patch. A common question from our customers is, how strong are our D-rings, or are they load tested? In this video, we set out to demonstrate the static breaking load of our D-Ring patch. It's in PVC fabric, and you'll find this patch on all of our inflatable boats. Please be aware, testing doesn't approve the use of our boats or D-rings for climbing, vertical lifting or vertical lowering. The types of situations you may find this information useful is the lowering and pulling of a boat against the current. Additional information on the forces endured on a rescue boat in this environment can be found on the study by Chris Onions titled Highline Rescue Boat Systems from 2013. To set the scene on the equipment we're using for this test, we're using a few stock items. One is a PVC thwart from a raft, which is made from the same construction fabric that we use in our Mega Sled, Rescue X Sled, rafts, and any other sheet fabric without using drop stitch. And that fabric is 0.9 millimeters thick. It's fitted with a Leafield C7 valve. And we've then taken a patch from our stock, and the patches are a 2-inch D-ring patch. The D-ring is sewn in the factory with a layer of nylon webbing, sandwiched in between 2 layers of PVC. That's then bar tacked either side of the back bar. That patch we've then glued, and we glued it in our workshop in the UK, and we glued it to the tube using Hybond's Extra Bond 3701 PVC glue.
Go out, Rollins.
Hello, how you doing? So here we are with WRS, and we're looking at a real world scenario, looking at loading a D-ring with a compound 3 on a 3 on a 3 internal system. So ordinarily you wouldn't put a 27 to 1 system through one D-ring, and we normally teach that you would obviously put a load distributing anchor point system in. But worst case scenario, say there's only one D-ring showing, you go for one D-ring, we're just going to explore what will happen. So just to go through our methodology quickly, we've used pulleys which are very efficient. They're probably going to be about 95% efficient within the system. And then we've used non-tufted rope grabs, and again, this is 27 to 1, a compound system. Our peak force, remember my mind, Lawrence, what was the peak force?
7.32 kilonewtons.
7.32 kilonewtons. So that's our peak force with 2 people pulling on flat ground with so personal size mechanical advantage, so 2 people pulling on a 27 to 1, so obviously double that 27. Problem we've got here is that with our rope grab, you can see it's caused considerable damage to the rope and that was our maximum pull, so we haven't stopped because of the damage. Unfortunately, we found the damage after our pull. We were about to go for a reset, but generally that was pretty much our maximum load of 2 people. But yeah, we've damaged our line. So that's 2 people pulling on a 27-to-1, and we can see that we still haven't had a failure at our single point D-Ring.
So our first test, and we've established that we're unable to exert enough force on a D-Ring and patch and the tube using standard rope rescue or river rescue equipment such as semi-static lines, rope grabs and mechanical advantage. Not to say these aren't useful items, it's just that we're trying to test the point of braking, and using these systems we can't achieve that goal. So we're now using a Turfer 1.6 ton winch with 11mm steel cable. To make the viewing pleasure a little bit more improved, we've decided to join the tests at 4.5 kilonewtons on each of the following tests, as we already know that the D-Ring will sustain up to 7 kilonewtons. So in conclusion, from our tests, we ran 4 tests in this particular series, each with an inflatable tube. And following these 4 tests, the average or mean average of the force required to initiate a fail of our D-Ring patch is 10.665 kilonewtons. The point of failure following our inspections were tearing of the webbing either at the point of the sewn bar tack or across the nylon webbing where the back of the D-Ring bar passed. No sign of failure was found on the tube, either on the glue of the patch or on the actual fabric of the tube. All tubes stayed fully inflated after failure. We also noticed deformation of the D-Ring, so the stainless steel D-Rings deforming on each of them following the test, but no signs of splitting, but just deformation. So hopefully you found some of that information useful, and one thing we can identify is really the importance of inspection of your craft, especially D-rings if you're using bows in tethers. So one thing we haven't looked into is the point of failure on an abraded or degraded D-ring, especially a point across the point of a D-ring back bar, so if there's any abrasion there. That is the point of failure in our test, and it's releasing at the stitching or across the webbing. So 2 points we want to check when we're looking at the boat is check that that stitching is intact, and also check that there's no abrasion over the top of the D-ring patch that's going to affect the nylon. The images I'm just showing you hopefully give you some indications of things to look for. Very similar, and to draw cross lines from things like harness checking, then there are parallels that we can draw across from worker height inspection into the inspection of these D-rings if we're using them in these sorts of environments with loads applied to them.